everybody. Welcome to episode 16 of our FM COVID-19 webinar series. And today we're going over strategies and operational performance and indoor air quality improvements during and after COVID-19. We have an awesome panel that I'm excited to introduce to you today. But before that, let's go over some quick housekeeping. Everybody has been muted for audio quality purposes. And this episode and all of the past episodes of the FM COVID-19 webinar series you can find in our Coronavirus Resource Center, along with a number of other great resources if you go to ifma.org/coronavirus. Moderating today's session is Carlos Santamaria. So let me turn it over to Carlos to introduce our expert panel. Carlos?
Hi, good morning, everyone, and thank you, Chris. I wanted to especially thank IFMA for the opportunity to allow us to bring up this very important topic at this current time, and also thank our presenters for their willingness to come on at this time of the morning on this day to present on some really important information. And I'd like to first introduce Dr. Mara Zatari, is the Chief Scientist Officer at Blue Box Air, and also Dr. Ashish Mathur, Vice President of Innovation at UVDI. So I wanted to kind of frame the conversation a little bit to talk about why we selected this topic and why it's so important at this time. In the last 4 or 5 months, building owners, occupants, and residents have been, really fearful about what the coronavirus, the effect it can have within the built environment. And there's a lot of misinformation. There's a lot of different strategies as far as what you can and can't do. And there are a lot of occupants that just will not enter offices or go outside of their residence in fear of catching this virus. But as time goes by, we're learning that there are some really good strategies into combating and protecting one and improving the environment. And also at the same time, there are some great proven strategies that have been in effect that allow building occupants and operators to not only improve the indoor air quality, but to improve energy efficiency within their buildings by anywhere from 15 to 30%. So in my experience, again, thank you again, IFMA and Chris, for allowing us to speak. Carlos Santamaria, I'm the principal at CEES-Advisors, and also I'm the regional director for the community colleges working with workforce development in the energy construction utility sector in the Bay Area and in California. And my role has been, I have 2 roles in my company. I conduct ASHRAE level energy assessments throughout the country and the world. So over the last 5 months, I've seen firsthand what building occupants, building owners, and individuals are doing to combat the COVID recirculation or contamination within a building to make it more safe for building occupants to come in. And my experience has been, there's been this increased level of fear, awareness, information that is being circulated out there. And it's really important for those out there to understand no 2 buildings are alike. So when we talk about some of these strategies, we really have to think about how your building's system is designed, what type of systems are in them, what type of air distribution we're talking about, the age of the building, the percentage of outside air, the types of systems that can be controlled, because there are a lot of existing buildings that have limited controls. The newer buildings have much better direct digital DDC wireless controls that you can control a lot of the devices, but at the same time, as I mentioned earlier, no 2 buildings are alike. So these strategies may not fit every single building, but there are some strategies and solutions that do and will cover a number, if not most, all of the buildings out there. So I want to go and start now and hand it over to Dr. Mara Zatari. And Mara, welcome.
Thank you, Carlos. Thank you for the great introduction. Thank you, Chris, and thank you, IFMA, and thank you for everyone who is joining our webinar. So we have a short time. So in this short time, I want to talk to you about some of the HVAC strategies, and I call it in the age of COVID. Next slide, please, Chris. So the consensus from different organizations is that the HVAC system is part of the solution, and it can actually play an important role in mitigating the risk of transmission of COVID. I put here the most sort of prominent organizations, and you can basically go and access the different guidance, pandemic guidance. And I put here in the middle a summary of the most common and most important, in my opinion, HVAC strategies. And I'm sure like many of you heard about these strategies. So the main one is filtration, and filtration, we're talking about particulate filtration in the return air stream. So filtering indoor air or return air, and can be central in your DOAS, in your air handling unit, or can be local, can be a consumer product, or can be like mounted in the wall or the ceiling. We have ventilation, you all heard, either minimum ventilation or increasing your ventilation, and also flush out. We have coil cleaning, we have cleaning in general. And then, as Carlos mentioned, we have many different strategies about ventilation effectiveness, air movement, etc. Now, the thing is that, I'm an ASHRAE member. I'm also on the ASHRAE Epidemic Task Force. And even for me, those recommendations can be confusing. And some of them are actually contradictory, and some of them are mutually exclusive. So the thing is that, like, how do we know which one is the most important one? Which two strategies go hand in hand? Which one will basically be contradictory? And also, as I'm hearing more and more, which one has the most negative impact on cost, our energy goals as a society, and also our environmental goals as well as a society? More than this, if I have a building with multiple spaces, which one, and I have a limited budget, like always, which one I have to focus on the first, or which one I have to prioritize? To give you an example, what if you increase ventilation, but you're no longer able to maintain temperature and relative humidity? And those, we know that we need to maintain a normal thermal comfort for our immunity. But what if you increase ventilation and you compromise the thermal comfort? Is that okay? Like, which one take precedence? Also, what if you increase ventilation and you live in a polluted city? And we all heard the reports from Harvard Public School of Health and Italy that link COVID-19 to outdoor air pollution, because apparently particulate matter can serve as a good carrier of the virus. So is it better to open the outside air if you have pollution or not? And one last example I really like to give, we've heard about increasing ventilation as much as possible. As much as possible, it means 100% outside air. It means all your supply to be 100% outside air. So if you go this route and you're able to, bear the energy cost, you're able to have still thermal comfort, then it doesn't make any sense to put indoor air filters, right? Because if you have 100% outside air, it means you have 0% recirculated air. And if you upgrade your filters, it's not going to be useful, at least for indoor air. Filters are always a good idea, but I'm talking specifically about filtering indoor air. So in the next few slides, I'm going to rank the HVAC strategies into 3 different categories and order them in rank of effectiveness. And then I'm going to show you an example, is how to do it using a risk assessment model. So linking risk assessment to energy cost first and recurring costs, and talking to you about the trade-off between ventilation and filtration. And then I'm going to end with coil cleaning and some of the things I'm doing regarding COVID-19 air quality samples. To start with, these are the 3 groups, and I order them by order of effectiveness. Cost effectiveness, first cost and operating cost, and effectiveness of removal of the virus. So the first one is source control. So what do I mean by this? Source control, by definition, is reducing the strength of the contaminant. You can talk about masks, you can talk about reducing the occupancy in your space, having a stage reopening plan, etc. Having a way to count people, having a way to basically scan for symptomatic people. So stuff like that. So this, we call it source control. Obviously, if you're not in the building, you're not going to get infected, but we're talking about, like a major source control where you enforce masks, for example. The second one is source removal. So source removal refers to measures such as cleaning, particulate cleaning, coil cleaning, and removing those contaminants that are released to the air, basically. And the last one is dilution. We've all heard before the solution to pollution is dilution, and it's ranked third on the big three categories. And it actually refers to reducing the concentration of pollutant using dilution. So supposedly you get outside air that's free of the virus, you get it indoor to dilute the concentration, and hopefully if you dilute the concentration to a dose that is basically low enough, that's not effective. So this is a nutshell, a summary of the three different categories. Now, let me give you an example. How we go about trade-off between strategies. In this specific example, I'm talking about trade-off between ventilation and filtration. So I'm using here a Wells-Riley risk infection model. It looks complicated, but the idea is simple. This model actually has been used for quite a long time by many different researchers in different fields. The first time it was used to study the measles outbreak in New York schools. And what it says, it gives you a probability of infection. And it links the cases of infected people to cases that are susceptible individuals present in this. And it says, how many what is the duration that you're spending in the space? What is your breathing rate? And then what is the generation rate of the virus? Are you wearing a mask, a good mask, not a very good mask, etc.? And then it says, these are the sources and the duration. And then let's talk about how can we remove these sources. And here I'm talking about specifically airborne COVID-19 virus. And I'm just talking about ventilation and filtration. So we heard, okay, increase your ventilation, increase your filtration. So I'm going to show you in this next graph and the next one is what does it mean in terms of risk and then in terms of cost. So this graph that you see, I basically ran the model for an office building, 40,000 square feet and 200 occupants. You can run it for many spaces you have. You can also repeat the choir case, the Chinese restaurant, the call center. You can use the same model to repeat what happened. Now on the y-axis is the risk of infection, is in percentage. The lower, the better. And the x-axis is how much outdoor air you have. The unit is in terms of air exchange rate, which is, a volume, volumetric of outside air. So CFM, feet cube per minute. And then you divide by the volume of the space, feet cube, and then you convert from minute to hours. So, and then I have 4 series. So I repeated the model for different filtration from MERV 7 to HEPA, and they are color coded. So the first observation is that if you go from MERV 7 to HEPA, your risk of infection decreases. So you go from something like 18% to 10%. The other observation, if you look at the last point in the graph, air exchange rate of 6. This is actually the point where you have 100% outside air exchange rate of 6. You see for yourself is that it doesn't matter what filter you're using, what we expect, because you're not filtering indoor air. So if you use 100% outside air, in this case, air exchange rate of 6, it doesn't make sense to upgrade your filters just specifically for COVID. Now let's talk what we have in buildings today. In buildings today, for an office, using ASHRAE standard 62.1 or the International Mechanical Code 2018, you have air exchange rate outdoor of 0.7. So you are a little bit less than 1. And if you look at the gray, so 0.7, and if you look at the gray graph where you have MERV 13, you see that you have sort of an horizontal line for the risk. What I'm trying to say, if you have your minimum outdoor air per standard 62.1 and you use MERV 13, increasing outside air beyond this does little to reduce the risk of infection. So if you have MERV 13 and your minimum outside air, you have a risk of infection that you can see on the screen, and you don't need to increase your outside air more, and that's, you can tie it to your energy goals. Let me show you one more thing. Chris, can you click one more click? Okay, so here is a summary of first and operating cost and risk of infection, specifically for Boston. You can repeat it specifically where you are. So the first row is minimum outside air. When I say minimum outside air, I'm saying the compliant per the standard. And then MERV 7, which we have mostly in commercial buildings. And then what happens if you upgrade just your filters, which is the second row from MERV 7 to MERV 13? And then what happens if you just have 100% outside air? And the cost I have here is relative to the base case, which is minimum outside air and MERV 7. So you see, if you have the minimum outside air, you don't play with your ventilation, you just upgrade your filtration, you're going to incur a cost because it's more costly to buy a MERV 13 versus MERV 7. But this cost is minimal compared that you have 100% outside air. If you're talking about existing buildings, obviously you don't have a first cost because you're not going to remove all your systems and then install new systems with more capacity. But this applies also if you're designing a new building. But you see that the relative operating cost is much higher for ventilation versus filtration. In other words, filtration is a cheaper option to run your building, and you have like sort of a relative risk of infection that's similar between upgrading your filters or adding 100% of outside air. So the takeaway from this is that there is a way that you basically talk about risk assessment without necessarily incurring a very high cost and basically increasing your cost and also increasing the burden on the environment. Chris, next slide, please. Okay, so I have 2 more slides. This one is about coil cleaning. And this is something that I basically recently started to learn about. And sort of, I usually, when I do the survey in buildings or air quality, I stop at the filter. Like I never, glossed over to see what is the secret of coils, or secret life of coils, I want to call it. So there is a lot of literature that say that a substantial evidence exists that coils can disseminate contaminants in the indoor air. That's even pre-COVID. You can see a lot of research about this. And then there is a very comprehensive literature that say that cleaning your coils semi-annually will basically decrease the burden of infectious diseases, headaches, and even improve productivity. And that's research from Lawrence Berkeley Lab. So what are the goals when we talk about a pandemic? The goals is to remove the biofouling, so the biofilm from the coil. And very important, not to use a technique to re-aerosolize particles that are stuck on the coil. And this was in an ASHRAE, from an ASHRAE expert in journal. So traditional coil cleaning using pressure washing or steam washing will not do the trick, will not meet goal 1 and goal 2. So will not remove the biofilm. At the same time, it has the ability to re-aerosolize some of the particles stuck on the coil. And also UV, specifically, if you have a fouled coil, will not also do the trick. There's a study that was done in University of Tampa where you had a very fouled coil. They put UV there for 10 months and you still see fouling. So on the fly, or if you put UV on the system, and if your coil is already fouled, biological fouling, it will not do the trick. And I show you here an example where you have, like on the left-hand side, you have before and after, and when you see blockage, and then basically here the recommendation is to use an enzyme-based technology that can basically, it has like a shaving cream consistency that can go through the coil and can remove any blockage. And you can directly see the breakthrough as you see on the screen. And one more point about this. If you have a blockage in your coil and you attempt to upgrade your filters or even increase your outside air, this is counterproductive. You have to clean your coils first mechanically, because what happens is that if you have a system that has, small to medium commercial system, and you have a fan that has constant speed, if you have a coil that's fouled, you have more resistance, and you end up to have lower airflow. So if you increase your ventilation, you're not going to see it here because it's not going to go through. Next slide, please. I'm going to end with this slide. So you can, besides implementing the strategies and having indicators of your strategies, most common one I've seen is carbon dioxide sensors. They're cheap. If you calibrate it well and well maintained, they work. And if you have carbon dioxide sensors, you can do continuous monitoring that you have good ventilation. So that's like indirect measure if your strategies are working. I've seen people implementing particulate matter counting to know if your particulate filters are working. So that's 2. The third one, it's a lab test. So it's not a continuous monitoring, but it can give you, specifically if you're looking for risk mitigation and sort of reassurance, a point in time, and you have to do it when it's occupied. We call it the COVID-19 testing. It's a direct test for COVID-19. You can have 2 things. One, swab test. Swab test can be on your filters, can be on your ducts, on your coils, can be on your dampers, can be on any space you have. And also you can do air sampling test, which is something I'm personally a big fan of, because you can do it in one location, or you can do basically an average in different location. And the air sample test gives you a test for everything. If your filtration system is working, your ventilation, if every single source control that you implemented is working, and both these tests test the RNA of the virus and can give you a concentration. It doesn't tell you whether it's infective or not, just tell you basically if it's present or not. Chris, next slide. So I'm gonna hand it off now to Dr. Mathur. Dr. Mathur, please take it from here. Thank you.
Thanks, Marwa, and thanks, Carlos, and thanks, Chris and IFMA for hosting this webinar. I think it's really important in these times. So Marwa did a really good introduction on what are the right approaches and strategies to adopt to basically be prepared for this pandemic. I wanted to focus on ultraviolet light, specifically UVC light, and how effective it is to combat and reduce the risk of infection in an HVAC system. As you can see here, this is a picture of the electromagnetic spectrum, and the ultraviolet range is typically from 200 to 400 nanometers. The UV which you get from the sun is typically UVA and B, and UVC is above the ozone layer, which is above the Earth. So on a relative scale, you can see that UVC is a shorter wavelength compared to A and B, and the UVC range is typically between 200 and 280 nanometers. Also, the shorter the wavelength, the higher is the energy. So you need to keep that in mind, because UVC, the higher energy, can be damaging to the skin and eyes. So it's always recommended to be used in unoccupied spaces, not occupied spaces. There are some new UV technologies which have been, I would say, touted out there, including far UV, which is on the lower end of the UVC spectrum, like 220 nanometers. So current data does not recommend that technology should be used in occupied spaces either. But there's some good studies which are showing that the risk of exposure would be less for far UV. But UVC is a tried and tested technology. Someone actually got a Nobel Prize in 1903 when they studied that microorganisms have a preferential absorption in the UVC spectrum. As you can see, that histogram, the graph here, it shows that the peak absorption of UVC for microorganisms is right around 265 nanometers. So, which is really a gift of nature, I would say, that, okay, microorganisms absorb UV. And then what is the mechanism on how UVC inactivates these microorganisms is in the next slide. Chris, if you can go to the next slide. Thanks. So this is basically you can see the DNA molecule with the double helix. So the way UVC works is, and we call it disinfection. What it's doing is it's really breaking the chain of the DNA molecule. It's the powerful UVC energy splits that molecule and makes it unable to replicate. So once it's unable to replicate, it cannot infect, and it would gradually die its natural death. So there's a difference between filtration and UV. Filtration, of course, captures a particle. The MERV-13 filters, which Marwa was talking about, they would capture the particle. And when you talk about viruses like coronavirus, the particle size is 0.1 micron in that range. So maybe a MERV 13 is not ideal, and people are even recommending HEPA filters. But again, that technology or the mechanism is captive. What UV is doing is it's actually inactivating and I would say killing that microorganism and not letting it replicate. Next slide, please. Chris, next slide, please. Yeah. So this is a really important slide, which basically says that the UV dose which is required to inactivate different microorganisms is different. When you see the three different categories, you see bacteria, virus, and mold, you would see generally the viruses are the easiest to inactivate using UV technology. Bacteria is a pretty broad range, and mold, of course, is the biggest to inactivate. And it's not just because of the size and shape, but it's a combination of what is the structure and the cell wall thickness of these microorganisms. So on a relative scale, viruses are the easiest to inactivate using UV. So it's really important when you design a UV system that you have sufficient energy to reach a certain level of inactivation which you desire. This particular chart is showing that, okay, what do you need for 99% disinfection? So as you can see that, okay, it's pretty low for viruses. Next slide, please. So today, most of the applications for UV are applied in three different ways. Traditionally, it's been used to disinfect the cooling coil. And the way it works is that the UV system is left on 24/7, and it doesn't let the biofilms build back up after any chemical cleaning has been done. And the second approach, which is used in a pretty large way during this pandemic, is Airstream Disinfection. We call it kill on the fly. So, and it's really important to make sure that the dose which you're applying for Airstream Disinfection is the right approach. Part of another technology which is used for air disinfection in a building is upper air disinfection, which is really localized UV cleaning inside the room, which is cleaning the air in the room. And the third one is surface room disinfection. So as the droplets and other aerosols and pathogens rest on the surface, on all the surfaces in the room, what do you do there? So that's where the whole room disinfection technology is getting increasingly popular. Of course, it's widely adopted in hospitals, but there's also a place for using UVC for surface room disinfection now. So next slide, please. So we're going to focus more on the Airstream disinfection as this is the most important need of the hour right now. It has been used for a wide range of airborne microorganisms. I would say tuberculosis has been the first and primary pathogen which was disinfected with UV. There's actually a World Health Organization guideline for using UV to combat tuberculosis and using upper air technologies. But UV in the ducts and in the air handling system has been used to disinfect influenza, the common cold, SARS, and lately coronavirus. Even mold spores, you might have heard that there was a case in the Seattle Children's Hospital where aspergillus was found in the operating room. So how did it get there? So the consensus is that it got there through the HVAC system. So either they didn't have proper cleaning of the coil or the outside air, there was construction outside the hospital, which might have brought the aspergillus through the HVAC system. And Legionella was another scare, I would say, last year, even though it's transmitted through water, but there's been also evidence that it gets transmitted through the air. Next slide, please. So how is UVDI, we call it UV germicidal irradiation, applied in the air handling systems? So there are two approaches. One is inside the air handling system, in front of downstream of the coil. Typically, it's put in front of the filters and before the coil. The advantage for putting it in front of the coil is you get a double benefit of not just air disinfection, but also coil disinfection. And the second approach is duct mounted. A lot of times, at least today, there is no opportunity or space to install a UV system inside the air handling system. So you would have to install the UV inside the ducts, and then you have to make sure that you have adequate coverage and those. The difference is inside the air handler, typical airflow speeds are like 500 feet per minute, 400, 500 feet per minute. The air velocities in the duct would be significantly higher. And we've seen as high as 2,000 feet per minute, which is not giving you enough time for a UV system to inactivate a moving air. So the key takeaways, I think the most important thing you need to know is that the formula, the dose is the intensity times time. So in an airstream disinfection, the time is related to your air velocities. So if your air velocities are higher, then you really need to have a UV system which is providing a much higher intensity and overall dose. This is an example that for 500 feet per minute, your contact time is only 0.25 seconds. So it's like a quarter of a second, not enough time. So most of the UV manufacturers are using UV modeling to figure out what is the right UV configuration to use to achieve that to achieve that dose. And like I said, if you put it next to a coil, you get a double benefit of achieving coil disinfection in addition to airstream disinfection. Next slide, please. So this is a dose table which we use to calculate what is the dose and what is the appropriate UV configuration to use to achieve that UV dose. In comparison to the influenza virus, there is, we call them rate constants, which tell us what is the UV dose required. So there is published literature which tells us what is the appropriate dose required to inactivate, say, influenza or coronavirus. So before coronavirus, most of our Airstream applications were modeled around influenza. And as you can see, the UV dose for a 90% reduction for influenza is, say, 1935 microjoules per centimeter squared. Coronavirus in comparison is much easier to kill because it is more susceptible to UV compared to influenza virus. So it doesn't need that much dose. So while you get 90% disinfection for influenza, you can actually get a greater than 99% single pass reduction of coronavirus with a properly designed UV system. So, and these are some examples of how the UV system has been installed. This picture is of a UV system inside a duct where the lamps are positioned parallel to the airflow. And the next slide gives you an example of how the UV system is applied inside the air handling system, which is right next to the coil, where the lamps, UV lamps, are perpendicular to the airflow, and you're able to add much more lamps because you have more space inside the air handling system. So I wanted to also mention, so when you have, say, a restricted area, for example, it's a coronavirus testing room or something, you do want to treat, you may want to treat the air inside the room as well. So the only way you can apply UV is in the upper part of the room, typically over 7 feet. As you can see towards the back wall, you can see some UV fixtures. They cannot be shining down because UV can be harmful to the skin and eyes. So they have louvers and baffles which are directing the air, the UV light outwards and upwards, and it's just treating the air on the upper part of the room. So you have to make sure that there is good recirculation going on in that room for this to be effective. And then this is an example of a UV device which is used to disinfect surfaces. Basically, you bring a UV device and you turn it on for a selected number of time, and you can disinfect all the surfaces where a pathogen or a droplet can reside. And this is widely adopted in hospitals right now. There's potential, and some facilities are also using it to disinfect commercial buildings, gyms, classrooms, and so on and so forth. Thank you. So I would like to hand it back to Carlos.
Okay, great. Thank you, Dr. Martha, and thank you, Dr. Zaatari. This is great information from both of you on your different technologies and solutions to dealing with some of these indoor air quality issues, especially coronavirus. There's a great question. So I think this segues us into having a conversation, answering some questions. And I'd like to answer the first question, which is a really, really solid question. And it involves, I'll just go ahead and read it. How do we establish a benchmark or baseline from which to compare the effectiveness of any HVAC strategy. The concern is that we will be able to, or can they be able to, the concern is that we will be spending lots of dollars with no increase in benefit to occupants other than an increase in psychological safety from hygiene theater. So this is something that I wanted to touch upon, that psychological safety, that perceived notion that any improvements or upgrades within a building are going to yield some returns. And again, depending upon the building, depending upon the type of solution, and depending upon your tenant or the occupant will dictate a different response. I know in the commercial real estate world and light industrial, many individuals are really concerned with the air distribution of what's being done, the perception. They're not so concerned with a particular type. They hear it out there, but they want to know the HVAC system, is it being maintained, the cleanliness, the cleaning protocols, the disinfecting protocols. Those are the things that seem to be most on individuals' mind. And once you go a little deeper with the facilities management or the engineering or the property management crews, they will give you the more specific information on what is being done, the different strategies, and what they're actually doing. But again, I want to present this question back to the presenters as far as, there's this what's called the psychological safety, but how do you provide information back to your customers as far as the items that you're implementing within a building, they yield benefits? So let's start with you, Marwa.
Yeah, thank you so much for the question. So in terms of the baseline, I would start with the minimum standard to be compliant. And this is really a chance to stick to the basics. Start is ask the questions. Is my system well maintained? I'm getting the minimum amount of outside air. Are my filters adequate to exactly where I live? Are they well, fitted? Are they well placed? And then am I getting, I said about the outside air. So I will start and stick, if I can, to the basics of if I know my building is compliant today before doing any upgrades. In terms of the communication plan, the one that I see and I'm a big fan of is to have a multi-layered strategy for coronavirus. There's no one strategy that is a magic bullet. It has to be a combination of different strategies, and also to have a shared responsibilities between visitors, between staff. If you're talking about theaters, I'm not sure if the question specific was about theaters, but also between the artists, and have this communication plan, very visual on the website. Have sort of round tables to see if we can do more. I've seen many signage, about the 6 feet, about hand washing station. You have it in the middle of the space. You have disposable mask, and then you have sort of, you need to be educated, your staff, to be to answer any concern that the visitor has, if you have an hotel, if you have a casino, or if you have an office building. But make it a shared responsibility between everyone, and usually it works if we say we are in this together. Thank you.
And Ashish, what would you comment regarding that?
Yeah, so I would say that you need to understand that UV is an adjunct technology to filtration. So if you don't have, say, even a MERV 13 filtration, then you know that you don't have adequate filtration. So UVC is going to increase the level of disinfection. And I mentioned before that it's not just the difference between a filter and a UVC system is capture versus kill. So when you want to achieve a high level of disinfection, you want to make sure that you have the right dosage for that. So
Great.
there's a very good information available on the ASHRAE website. So there's chapter handbooks which tell you what is the right way to apply a UV system, and you can use that as benchmarking whether what a manufacturer is suggesting is in line with what the ASHRAE recommendations are.
Great. And I think most building owners and operators, they're going to look at what those minimum standards are, operational best practices. You know, we don't talk much about back of the room operations, and that's what I get to see, and many of you get to see out there, is how are the facilities individual maintaining the equipment, you know, their records, just the general appearance. Those are really important things. So I'd like to go to another question, and there was a number of questions that were sent in, and we'll start with, I believe, Ashish, can you answer the first one? And I think that was, you had committed to one of the questions there. If you want to go ahead and take it, and that, what was that?
Yeah, I think that question was from Christian. He was talking about what additional technologies do you need to purify the air in addition to filtration. So I've covered that a little bit. When people talk about purification of the air, in this context, we're really talking about disinfecting and controlling the spread of infection. So again, filters are capturing the microorganisms, and UV is actually disinfecting these virus particles as they're going past the UV system. So yes, UVC is one of the most effective technologies to disinfect and purify the air from these particles. Thank you. Carlos, back to you. I think you're on mute.
Yes, thank you very much. Sorry about that. Mauro, can you take the next question that you had mentioned you would? Sure.
So the next question was by Richard Copenhaver. Richard's question is, elevators seem to be the most dangerous environment within a commercial building with relation to COVID-19. What are the best practices? Thank you so much for this question. It was always on my mind about elevators, and I was thinking like it's time maybe to take the stairs, you know, instead of going. But I want to talk about the facts. So elevators, you take a short trip. Usually it's around, you know, the average is 1 minute. They're very well ventilated, 60 air exchange rate per hour or 1 per minute because you're opening the door. And in elevators, airborne transmission is very, very minor, doesn't exist. And we focus specifically on the close contact. So what are the best practices? And then I'm talking about the risk. Best practices, and many of you have seen this, don't have a crowded elevators. I've seen people put signage on the 4 different corners, stand there, and unfortunately to say this, but face the wall of the elevator. Do not speak. There is something called, you know, speaking etiquette. Wear your mask, and you know it's obvious to say, but don't cough. You know, don't cough, don't sneeze, try, you know, and don't speak. And someone, Dr. Richard Corsi, did basically an analysis. What is the risk if you talk about the risk of being in an elevator or being in a restaurant? And he repeated the experiment in the restaurant in China. And he basically reported in terms of the volume of aerosol that you inhale in your respiratory system. He said if you are in an elevator and you cough and speak at the same time, you will have 100 times lower risk in terms of the volume of inhalation of the virus compared to sitting in a restaurant. If you go in an elevator and you don't cough and you don't speak, you will have 1/1000 lower risk. So I don't agree that the elevators are, you know, a major risk compared to other indoor environment. But if you want to take the stairs, then go for it.
Great, thank you for that. So I'm going to take a question that was provided by Paul Grabovec, and it reads, run 100% fresh air to defeat coronavirus, air tighten buildings to make it affordable. Now, the question on 100% outside air comes up all the time. And individuals, as we started with the coronavirus, the misinformation, not knowing much about it, not knowing what strategies to implement, owners' concerns have always been about, you know, there's a balance between cost effectiveness and risk assessment. And as time goes by, the risk assessment component is really coming in more. And I wanted just to let people know, and I've had several conversations with, very scientific, bright, knowledgeable individual from a lot of different parts of industry. And I don't think I've had too many, if any, disagreements with my perception of that. The air distribution route or the pathway is basically a graveyard for most viruses. Not all, but for most. And depending upon, as I mentioned earlier, the type of system you have out there, not all buildings, remember, have 100% outside air. Maybe 50% of buildings have outside air. So what do you do with the rest of the buildings that have minimum outside air, or the pathway is different? For large commercial industrial buildings, the pathway, you need to go through ductwork runs, different angles, different materials. And as Ashish had mentioned with the coronavirus, it's a pretty fragile virus. It loses its strength depending upon temperature, humidity, and the material that it's on, or it just dies. So when you're talking about the air distribution, you're talking about different obstructions throughout there, return and supply air, louvers, baffles, return air plenums, the ductwork, mixed air plenums, the filters, the coils, the fan intake, and then, both the supply and return air vents. But what I think most individuals can really bet on and have a defensible strategy is making sure that you're doing, from my perspective and my conversations and my observations and going into a lot of buildings, is to be able to check all the boxes. You're having the minimum outside air as compared to what ASHRAE standards are. You're maintaining the building. You're using solutions that, whether they're UVDI or the blue box, to where you're disinfecting the coils. You're making sure there's no biological fouling. Years ago, within cooling towers were looked at quite differently than they were today. And because of some of the contamination throughout different buildings that just did not take care of the biological fouling within the towers themselves, we had sick building syndrome and a lot of problems, perceived problems that every building could have that, which is not true. Getting back to the airflow and the 100% outside air, we just have to make sure that we understand the amount, what the facilities people are doing, and using strategies that not only improve the indoor air quality, but improve energy efficiency. We're not talking much about energy efficiency now, but we have to, because in some applications, running 100% outside air really disrupts your mechanical systems, your temperature, you're maintaining a particular static pressure. There's a lot of metrics in there that need to be considered. So I'm going to go ahead and read off another question, and I'll leave it up to Mara or Ashish or whoever would like to take it. What can a tenant do? And this is by Lazane Murphy. What can a tenant do in an office tower to ensure the best air quality? What information or standards should we push our landlords for?
I can start, Ashish. So,
okay.
It's a very good question. And there is a lot of guidance out there. There's the IFMA guidance, and complementary as well, the ASHRAE COVID-19 guidance. And there's a minimum standards, and of course the mechanical ventilation, International Mechanical Code. So as I mentioned before, I would start with the basics to know that the building is well maintained, well kept, run, and whoever is running the building are well educated, not only on saving energy, but also on indoor air quality. And this is, a little bit sad to say this, but this is the compelling event that will put indoor air quality on the table. We're waiting, for an event so we can have indoor air quality on the table, either on the design table or on basically the different how to operate a building. You operate a building for thermal comfort, to save energy, save the environment, but also to ensure good indoor air quality. And that will follow, the health of your occupants, productivity, etc. You can monetize this one. The other thing I want to say is some of the guidance are in gray area. a lot of organizations cannot basically say, oh, we like this one product or we like this one company. So you still need to do, besides having to follow guidance, standards, you still need to do your due diligence and dig into the detail. There's nothing that should be in this day and age that is prescriptive or because the manufacturer said so. You need to dig into the details and do a performance-based approach to your specific. Even if you buy a MERV 13 filter, the MERV 13 filter, there's different efficiency even within the MERV 13 filters. There's different pressure drop. You can get a pressure drop, a very low pressure drop, and use MERV 13, and don't compromise on your fan, on your energy, etc. So dig into the details and ask for a detailed concept and calculation. So if someone is trying to sell you something, dig into the details. Does it have a method? Did I obtain the third-party test data? How does it apply to specific of my building? And more importantly, compare the different strategies. So if you have a limited budget, which I'm sure we all do, put it in the right place and in the right space. Thank you. I don't know. Ashish,
Great advice.
Yeah, if I may add, I think Maura's covered most of the important features, but in our experience, what we're finding is compared to institutional buildings, commercial buildings and offices don't really maintain their HVAC systems properly. There's time and again we've seen that the filters have not been changed. So, and not just going to MERV 13, that's typically not even seen. You typically see MERV 8 filters. So that's one thing. And secondly, the maintenance is not good. You see these coils, which are really foul, and they don't know what to do about it. I can say that in our building, we have upgraded our filters. We make sure that the change out of the filters is done according to the manufacturer recommendations. Have a annual inspection whatever the periodic inspection is required, 3 to 6 months of the filters. And then during this pandemic, if you have the space, add some additional technologies like UV if you're not able to provide adequate outside air. Yeah, thank you.
Sure, thank you. Those are some great bits of feedback, and I'm glad, Maura, you had mentioned, certain practices, and Ashish on the perception, and I agree. The HVAC systems are not being maintained as well as they could. I think we're at a point now where we have a reset on retraining crews on what needs to be done, what should be done, and those strategies that enhance the indoor air quality and the energy efficiency. I did want to mention, and Maura brought it up, that IFMA just recently updated its pandemic manual, and it's a free download, and there's some great information on operational best practices, strategies with cleaning, different innovations, and they talk about the air distribution. So it's a free download. Look at it on IFMA, and it's there for your use. So let's see. The next question.
Actually, Carlos, I think that's about all the time we have on the Q&A. Thank you so much to the panelists. Thank you, Dr. Mathur and Dr. Zaatari. This was an incredibly informative episode. Thank you, Carlos, for moderating today's session. We've already gotten feedback from the audience, how insightful it was. So big thank you to everybody for participating. And sorry we couldn't get to the audience's all the questions. A lot of wonderful questions came in. Just for everybody's knowledge, we will be compiling all those questions and working with the IFMA fellows and subject matter experts to come up with some comprehensive ways to answer that stuff. Next week, we're going to be doing episode 17, where we're going to talk about technology and automation and how it can improve operations and maintenance in critical facilities. So please look for that registration link. If you go to COVID-19webinar.ifma.org, there's a registration page up where you can sign up for that episode. Also, as Carlos mentioned, yes, the foundation has recently updated the pandemic manual. And then we've also got this webinar series and the strategic framework that was produced by IFMA's rapid response team. So those kind of IFMA coronavirus essentials, you can find that. You can find all the episodes of the webinar series by going to our Coronavirus Resource Center at ifma.org/coronavirus. coronavirus. So thanks again to all the panelists. Thank you, audience, for attending and making this such a great episode. We'll see you next week.